Whoa, wait. What is that? Oh, okay, never mind, guys. That was a scare. I thought there was an asteroid out there, but we're safe for now. At least I think we're safe for now. With roughly 2,000 asteroids that are potentially dangerous that have been spotted, it's actually a very serious concern. Asteroids, which are remnants of planets or just large jumbles of space matter, are made up of rock, stone, and metal, and have proven that they can cause a lot of disaster to life on Earth. Now, we don't really want to end up like the dinosaurs did, so here's how to defend the Earth from asteroids. Step 1. So, it is key that we detect the asteroids way before they get to Earth, because we need time to be able to save ourselves. So, here's an image of space from a telescope, and as you can see in that pink circle right there, there's an asteroid. Now, maybe you couldn't see it that well, so I blew it up for you. See, now you can easily tell it's an asteroid. Well, that was the problem they had until Amy Meisner and her team developed a new radar or detection system using infrared technology. Now you can clearly see where the asteroids are, as they're highlighted in red. Except I didn't highlight those. That's just how they show up. Because on the infrared technology, it uses heat instead of light, which captures the asteroids, but not the planets and stars around it. That's because the asteroids, which are a lot smaller than the planets, capture the heat from the sun and reflect it in the infrared technology. Step 2 is deflection. So once we've spotted these asteroids, we have to keep them from hitting the Earth. Now, I say step 2, but it's honestly more like step 2 through like 1,000, because this part's really complicated. So we have a few options. One option is to just try to hit it with something and deflect it from hitting Earth. In this photo, we used a kinetic impactor, which has actually been used. This is a real photo. And the kinetic impactor struck the comet, and it deflected it and derailed it off the course. Now, this one wasn't going to ever hit the Earth, but it was a theory that was proven to work, and so now we have it. Another option we have is more of a concept, but it's called the space tug method. And this method is when we launch a probe all the way to the asteroid, but instead of just hitting it and like trying to move it, this gradually pulls on it with a long life gentle force, which according to Russell Schweickart and his team, they've estimated that over 3 months it will change the orbit course by 1 centimeter per second, which isn't much, but it's just enough to make it miss Earth or any other thing we're trying to make it miss. Now, another method is to concentrate solar energy into a laser of sorts and disintegrate parts of the asteroid, changing its shape and thus changing its course. Another similar method is using a laser that we've built. Now, in this design, which was brought to us by Hussein Rosenbeck and Utrilla from the International Space University, it's actually on the moon. And by putting it on the backside of the moon, away from the Earth, it bypasses any laws or regulations preventing us from having lasers in space, which is actually quite a big problem because none of the governments want anybody to have the technology to have lasers that can shoot down on Earth. But this way would bypass it. Now, if none of these technologies work, we have one more option. And that is to accept our certain death. We will join the dinosaurs, and then maybe, who knows, maybe another civilization someday will be in the same spot, wondering how they can protect themselves from asteroids.
All right, Zach, how did that go?
It's over.
Yes, it is.
I think I was pretty nervous. I think it showed. I was talking loudly and fast.
Okay.
But I don't know.
What did you like about it? What worked for you?
I liked having like the PowerPoint to like reference. That was cool.
Okay. All right, audience, if you could please offer some feedback.
Honestly, you didn't really show that you were nervous, and I thought you did a really good job of knowing what you were talking about, and you barely looked
I really liked your use of visual aids. I think the topic is like kind of complicated and some people are like unfamiliar with it, but the visuals